Obviously, selling hydronics is very challenging. We see this very frequently. Unfortunately, a large part of my job is going out to job sites where end users are not happy with the installation. We look at the installation, and there's a lot of deficiencies that come into play. And sometimes the contractor gets blamed, sometimes the engineer gets blamed. What do you think are the biggest challenges we face, and why do we end up in this scenario so often where systems don't work, don't provide comfort, a whole bunch of boxes we can tick?
That's a big question. So, well, in terms of performance and design, that's a complete subject all into itself. Getting builders and clients and contractors and vendors, um, solution program, that's another subject altogether, right? So let's start with getting people to think about hydronics and using hydronics, and then that's maybe talk about design and installation and commissioning and equipment and that type of stuff. So I have to share with you, that in the beginning, like long time ago, like decades ago, and I'm talking like back in the 80s, hydronics was for us, well, we would go into every conversation and saying, well, you ought to buy hydronics. And we would get into all these discussions about efficiency and comfort and blah, blah, blah. And yeah, we were somewhat successful with it. But it took, unfortunately, because I'm not that smart, it took like 3 decades later where we realized that hydronics was a tool. It wasn't the story in itself. And when we started to learn about human physiology, human psychology, architecture, design, and able to understand what people wanted inside their homes, in terms of environmental systems, sound, lighting, odors, vibration, thermal comfort, air quality, all of these types of things, that hydronics became the tool for us to achieve many of those indoor environmental requirements describing to us. No one ever came to us and said we want a hydronic system. We had lots of people come to us and say, well, we don't like the overheating, we don't like the cold floors, we don't like the drafts, right? And that's what they were describing to us. So it took us 3 decades to get smart and realize that people will tell you what they want, and then the tool to achieve that is a combination of architecture, enclosure design, interior design, and mechanical systems, which includes hydronics. And the radiant played a big role of that. And whenever we hear people trying to solve radiant problems with convective solutions or convective problems with radiant solutions, we just shake our head, because that approach doesn't work. If you've got radiant problems, solve them with radiant solutions. If you've got convective problems, solve them with convective solutions. But don't try to mix and match. That's right. So once we understood what our clients really wanted, we were able to, in our knowledge of these other metrics, so I call them the 4 horsemen: architecture, enclosure design, interior design, mechanical systems. Then we were able to, okay, now clients know what they want. They want great indoor environmental quality, and they want a reasonable understanding what the energy pain is going to be. And we can solve a lot of the energy pains by fixing the architecture first. And we can solve a lot of the comfort problems by fixing the architecture first. And we can solve a lot of the air quality problems by fixing the architecture first. In fact, there's a lot of things that can be fixed by the architecture. And when you can get the architecture right and the enclosure design right, which is part of architectural design, and interior design, then all of a sudden mechanical systems become much simpler, much more efficient. Conservation of energy efficiency, and then also exergy efficiency today, but that ultimately is the goal, should be the goal for energy. So that's a big paintbrush on a really high level, right, Michael? And then if we get into, okay, let's say they pull the trigger and they say, okay, fine, we're gonna, Mr. Bean, follow what, right? So then we would proceed to do design work, and we did comprehensive design. For those that are familiar with the designs that we did, it wasn't a couple of 8.5 by 11 pieces of paper. We produced a full set of drawings. Sometimes these drawings were, 14 pages of large size format, and we did everything, architectural solutions, enclosure solutions. So we provided comprehensive design, and then the mechanical systems. And then our job as the consultants, as the job should be for consultants, is to what you have in your calculations and in your drawings is actually, developed on site. And that means you have to be engaged. You have to get onto the job site. You have to see what's happening, and you have to call people on their crap.
Yeah.
With some political finesse, right? But sometimes it takes a 2x4 to the side of someone's head to say, why did you do that? Like, that's just not going to fly. It wasn't in our drawings, wasn't in our calculations. So why am I seeing it here? Like, time out, stop the presses, take 10 steps back, and let's get realigned to what's supposed to be on site.
I think
And
one of the key things, Robert, that you touched on, which is really, really important, and I see this, and I sometimes do it and try to stop myself, is that people don't seem to understand, and I include myself in that selling hydronics is not about selling a boiler. It's not about selling a TACO circulator, right? You really touched on it well. If I go into some dentist's home and start pitching them on a IBC boiler or a water furnace water to water, they have no idea what that is. The number one thing we are selling is comfort and solving a solution, like giving them a solution to a problem.
Right. Yeah, that solution requires integrated knowledge. We've all seen it, and we talk about it. And I know John, Siegenthaler, I think he's there in the room, and talking about going in mechanical rooms and seeing like 30 circulators on the wall, and you're just shaking your head because I know John's the same way. And when I see 30 circulators, I don't see 30 circulators. I see 30 motors, and probably on a good day, those motors might be running at 20 to 30% efficiency. The rest of it's heat, the rest of it's vibration, noise.
Yeah.
The energy gets converted, right? Some of it goes to moving the water, but not all of it, right? And so, I see that kind of stuff, and it's what happens for those of us that have been doing this a long time and have background in energy systems is that we see that kind of stuff and we go, no one did calculations.
Yeah. So
it wasn't done.
Look at it, Robert, because you have so much more experience with it, and you're exactly right. Like the room I was just in this morning when we were chatting on the phone, there's literally, I'm not even exaggerating, 40 circulators on the wall. I wish I had a photo I could throw up right now. I'll present it later. And I look at that, and that's a deficiency that happened after the sale, right? That is a lack of design. We call that engineering by contractor. I say that with love because I came from a family contracting business, right? And I had no business designing systems when I was installing them. So if you look at it, if you are the contractor and you're about to meet with that builder, if you were to list, the top 5 things that you think are important to discuss and translate to that builder or end user, what would you start with? Because I know it wouldn't be, here's your IBC boiler and here's all its features, because the homeowner doesn't care or know.
That's the last part of the discussion. Like people, so again, like going back, if I look back and I look at the last as practicing engineers, we would have like the very first conversations would last 2 to 3 hours. Only a half hour at the very end was about the mechanical systems.
Yeah.
So if you lead with the mechanical systems, people's eyes are just going to glaze over, and so our first thing, was to have an understanding of what the objective of the client was. Was this a retirement property? Was it an investment property? Was this a property that was going to be, handed down to several generations in the family? Like, we wanted to know what was the ethos of this project, right? And then we would get them to think about, okay, so, and most of these customers had already lived in 3 or 4 houses. This is oftentimes our clients were, building their last home. They were going to die in this home. So their requirements were different than somebody who was going to flip the house, in a year or two, right? These were people that were going to live in it until they died. So a little bit different needs. Well, you don't understand those needs unless you start asking questions, right? What are your expectations for the thermal environment? What are your expectations for the sound? What are your expectations for lighting, right? And that type of stuff. And so when we understand that, then we can take the client through the process of designing their home not the mechanical system, that's part of it, but it's designing the project. And there's a huge disconnect today, unfortunately, between the ability for people to express their expectations and for the contracting community to understand those expectations and then translate them into a finished product. And I'm not talking about the mechanical systems again, that's just part of it. You know, it's about talking about solar shading, that's talking about window performance, you know, it's talking about colors, it's talking about interior finishes, right? I mean, a big subject right now is indoor air quality. Well, part of indoor air quality, I know Gord Cook's probably in the room there, you know, control, right? If you want something to break down into gases and particulate, hit it with sunlight. Well, if you've got a window to wall ratio that's whatever, say 90%, and someone forgot to talk to the client about solar control, you got all the shortwave radiation hitting that synthetic carpet. Well, what the hell do you think happens to it? Right? It turns into formaldehyde and toluene and benzene and whatever gas you want is coming out of that carpet. And then, of course, then you end up with particles, right? So it's not, you can't go in just selling the hydronics. You have to go in understanding the building, the client, what it is it all are about, and help them make good decisions. And the hydronic part of it is part of the solution. It's one of the tools that you have to address things like thermal comfort. And there is an impact on air quality with, you know, particularly with irradiance systems, right? So you know, again, like if you really understand material sciences, materials of construction, right? They break down due to temperature. So if you, and we know this happens where there's imported flooring, hardwood flooring, or laminate flooring, if you will, engineered floors that come from other parts of the world, incredibly high levels of formaldehyde. Well, if you want that formaldehyde to outgas into a space, well, heat it up. Well, if you're doing radiant designs and you're not paying attention to operating temperatures, let's just say you have a really high load in a building, whatever, say 30, which is starting to approach the maximum from a surface temperature. Well, you could be easily running, you know, very high temperatures, 120, 130 degrees, depending on the system that you're designing. Well, now you're going to start to outgas into the space because of your floor heating system, right? So you need to say to the client, time out, right? The entire reason for radiant is low temperature, not high temperature. I mean, we can melt snow and ice with the systems. Let's not talk about performance capacity because we get lots of performance out of it, but we have to understand the relationship between the temperatures we use and its impact on indoor air quality through the degradation of flooring materials, right? So when you start to see that, then you can start to say to the client, okay, listen, this high temperature load that you've got going on here only exists in this one particular zone. So that's reduced the thermal bridging. That's add some exterior insulation. That's reduced the window to wall ratio, right? That's maybe go to a triple pane instead of a double pane. That's add a couple of coatings, maybe 180, 366, you know, some kind of thing. And we're going to get that load on the cooling side and the heating side down for that particular zone. And now instead of running at 130, now we're down to 90 degrees Fahrenheit, right? Like surface temperature of your skin, right? Like that's the whole designs, and everybody should be doing this, right? Is you should be looking at all of the fluid temperature requirements, let's say for a floor heating system, and harmonizing them. Like this business of having 5 or 6 or 7 design temperatures, all it does is it creates complexity in the hydronic system because now you have to have mixing systems. A lot of these projects you go on and you see like 30 circulators is the temperature profiles in that project when they could have been solved with architectural solutions so that you have one temperature, not 30 temperatures. You know what I mean?
Yeah.
So
I think a lot of it too, Robert, it comes back to that discussion of, you know, don't do your design the day they sign that order in the mechanical, right? It's, you need to work with a partner and a collaborator, but I think from a, you know, a selling aspect of it, the biggest thing that sort of gets overlooked is what are we actually selling here? And the number one thing that we're selling is comfort, in my opinion. And we can safely argue that hydronic is definitely the most comfortable. And then the other thing that comes into place is efficiency. Again, coming back to John Siegenthaler, looking at BTUs per watts, nothing is going to beat a properly designed and efficient system. One of the things I see a lot that you can speak to, hopefully, is there's a misconception that a hydronic heating and cooling system, so we'll say it's an air to water now, we'll move past boilers, is more money than a forced air system. And the reality is it's not. If it's properly designed, there may be a small premium at the front, but I always say to people, do you want to pay a little bit more up front to pay less for the life of the home? Or would you rather to cut corners and pay less up front, and then every single month you're hit with this massive hydro or gas bill? What are your thoughts?
Well, again, it goes back to, the engine in that home. If we're talking about a heat pump, a COP that the manufacturer has in the equipment, right? So it comes out of the box and it has a capacity to deliver a certain amount of heat and coolth, and but it's not just a matter of setting it in the mechanical room and hooking up pipes to it. You actually have to create the conditions for it to achieve what that engineer designed into that machine.
Mm-hmm.
And that means you got to do some math, right? So if you want to, on the heating side, if you want to be, extracting the most amount of work out of that thing and getting it to deliver the COPs, well, then you have to be returning water temperatures, in the 80 degree Fahrenheit in the heating side, right? All of a sudden the heat pump COPs go through the roof. Same thing on the cooling side, right? If we can return cooling water temperatures, somewhere in the 60 degrees area, we don't need 50 degree temp. 60, 65 degrees is possible. But again, it goes back to, in order for that machine to achieve its highest performance rating, it's an integrated system, which means you have to look at the architecture.
Mm-hmm.
There's no way around it, right? And you've seen it, I've seen it, everybody there in the room, Lance, Gore, John, all the talent that you have there, I've seen it where you go into job sites and some owner has bought into the story about high efficiency equipment, but the system doesn't operate in the set of conditions that allow that equipment to do what it's supposed to do because nobody did the math.
Well, and so Robert, we're seeing that now. Like I like to read the UK papers, and in the UK, the boilers are out. It's heat pumps, and there's front page stories of people enraged over their heat pump installations, and it's because it's a boiler mentality. I did a webinar on this called "Boilers Are Not Heat Pumps," and all we did was show how to pipe a heat pump like a boiler and how badly that's going to perform, right? So I think that, the challenges we see in the selling of hydronic systems is, number one, a lack of knowledge. And that lack of knowledge is lack of knowledge on the equipment, but also lack of knowledge of what does that end user need. The other thing that I see that I don't have a good workaround to that hopefully you do is that in a lot of cases, the builder or the architect is in between the contractor and the homeowner. So what happens is we don't have the opportunity to have that value proposition of understand we're going to give you a more comfortable, more efficient system that also meets your architectural requirements of no bulkheads or whatever it may be. What do you think is an approach to try to communicate more effectively so we can get some of these builders to understand why contractor A is putting a hydronic system in for $15,000 versus the contractor B who's doing a forced air system for 12?
Right. So again, that goes back to education, but also educating the building, but educating the client. And again, we always, and it's right on our website, we, when we were practicing, we would say like the best time to approach a designer, somebody that has integrated design knowledge, is before you hire an architect. Because once the architect gets involved, then they're going to take the client down this path, which is based on visual stimulation, as opposed to when they come to somebody who understands integrated design, we're going to take them down a path of indoor environmental quality in all of its aspects. So again, sound, lighting, thermal, odor, vibration, air quality, and then we're going to give them an energy allowance. If you build your building with IEQ in mind, That will establish the window to wall ratios. It'll establish the thermal performance of the enclosure. It'll establish the leakage rate in the building. It'll establish the interior finishes. Like all of the IEQ stuff will set the parameter for how the building should be designed, and the energy budget will tell the architect, what the thermal performance of the enclosure should be.
Well, and Robert, you've touched on something really interesting that, if you take an approach as a contractor, get in front of the architect, hopefully there's not too many architects present, we say it with love. If as a contractor, you're focused on comfort, efficiency, and IEQ, those are three things that any end user can understand, and they all translate back to a radiant system.
Yeah, so and you're absolutely right. And when you think about sound, for example, right? I mean, if you are looking for something that's incredibly quiet, there's nothing better than a hydronic radiant system. It doesn't mean, not so much in Canada because we're required to ventilate our buildings, but in the US, we do hear people say, well, if you go radiant, you won't have to, have air blowing around. Well, you still need air for ventilation, addressing the air quality issues, but the air quality is addressed with much lower volumes, and the ducting can be or designed for much lower velocity. Very quiet ventilation systems working in parallel with the heating system, which has been our philosophy ever since I graduated. That's what I was taught. We treat thermal comfort systems separately from air quality systems. The standards reflect that, and our bodies reflect that, right? It's only in North America and other parts of the world too, but where we try to use one system to do all the functions, and it never really works very well, until you separate them out. So sound, right? The thermal part of it, the thermal comfort, there's no doubt about it. But we also have to keep in mind that 60% of the sensible heat transfer from the occupant to the environment is radiation. So if we have a crappy enclosure, where there's cold surface temperatures, a combination of cold surface temperatures of the walls, the windows, floors, and ceilings, having a radiant system allows you to compensate for that. But you can also have a high performance enclosure, where there's very little thermal bridging, the surface temperatures are approaching ambient temperatures. Well, then it's harder to make the case for a radiant floor heating system. But that doesn't mean you can't use hydronics in some other form, either in an air handler or panel radiators or radiant walls or radiant ceilings, right? But we have to be careful, and we saw that coming actually many, many decades ago, where people were selling radiant heating. Well, you're going to have warm floors. Well, that was maybe true, right, when buildings sucked. But as we're starting to see the high performance enclosures, some of these buildings don't need warm floors just to provide the comfort. And again, part of that goes back again, like having people understand what comfort means. I mean, when we're from a heating perspective, it means we're retaining heat. Our bodies are retaining heat. It's not that the space is warm, we're warm. And so the enclosure does that. It allows us to retain heat. If there's any flaws in the enclosure, then we can augment that with a radiant floor heating system or some other hydronic system. And then that, conditions to retain our heat. That's what it's all about. On the cooling side, if we have a building that sucks, then what ends up happening is that, we got solar gains coming in through the window. That's all shortwave, high intensity radiation. There's no way our body can discharge heat against that, right? So we start to overheat. And the reason why is because we can't get rid of our heat fast enough because everything around us is so warm. The glass is warm, the ceilings are warm, the floors are warm, everything's warm, right? And you can see in this room I'm in today, this is actually an old sunroom. This was a 1950s farmhouse. They slapped on a sunroom onto the side of it. It was all glass. One of the only few people in North America that actually got rid of the glass. Everybody's trying to add glass, right?
So Robert, I'm in the opposite, as you can tell from the reflection and the large windows next to me. I'm in a sunroom.
Right. And so what ends up happening, the glass gets hot. It gets hotter than your body. So you can't actually discharge your heat to it. So you end up overheating. And it's the overheating that causes, to feel uncomfortable. So you can't ignore the inside surface temperatures because roughly 60% of that heat exchange is done via radiation, right? So radiation can be controlled with architecture, enclosure design, but also through your choices of mechanical systems.
Yeah. So if we talk about cost, because cost comes up an awful lot,
Mm-hmm.
I look at the cost of a system and I think that people get hung up on the cost for a couple of reasons. There's still a lot of engineers and contractors that are designing systems like it's 1986, right? And if we keep designing systems like it's 1986, a system that could cost $5,000 could in fact cost $10,000 because we're throwing all of these ideas that were great ideas in the 80s. But as I like to joke when I'm doing training, newsflash, we're going to Mars soon. Like we can't do things like we did when we went to the moon.
Mm.
So do you see the same thing? Do you think a lot of these concerns over cost and where costs balloon are a result of education and knowledge, or is there something we can do differently?
I know, and everybody in the room that's done a lot of design work, you can look at a set of blueprints and a mechanical system, and you can find thousands of dollars of wasted money, that oversized pipes, oversized pumps, circulators, oversized boilers, heat pumps, everything that's oversized. Thousands and thousands of dollars. Or you can look at, the complication in systems, which adds more money, right? So, just take for example, right? If somebody doesn't optimize the fluid temp, they just didn't understand that by changing architecture, you can just get everything down to a single temperature, right? So all they do is they look at what they have because they're a mechanical person, so they don't understand architecture. So they just say, okay, well, this is the architecture, and here's the floor coverings, and here's the loads. Well, 30 degrees over here, and I got to have 90 or 85 over here. So now I need a mixing system.
Yeah.
Soon as you add a mixing system, you're adding a couple $1,000 because you're going to add controllers, you're going to add a circulator, you're going to add more piping, more electrical work, more work to commission the system. It just starts to get complicated when the solution actually wasn't a mechanical solution, it was an architectural solution.
Yeah.
So the money that goes into these mechanical systems, often the wasted money goes into because somebody tried to solve a mechanical problem with a mechanical solution when it was actually an architectural problem, an architectural solution.
Yeah.
And then, so that's that. And then you get individuals that enter the marketplace that don't quite understand, what it takes to actually do a system. So they overprice it, and we see that quite a bit. Yeah, it's, Michael, it really comes down to when you look at the pricing that goes into mechanical systems, the experienced person understands the integrated process, simplifies the mechanical system, right sizes everything, then you're going to start to get costs that really are a better representation of what the client ought to spend. And the infuriating part about that, and people need to listen to this, listen to my words here. For every $1,000 that someone spends unnecessarily, that's $1,000 that's gone forever, that could have gone into something with much better effect. Improved windows, right? Get somebody, if I mechanical systems where there's been like close to $5,000, $6,000, $7,000 of poorly spent money, had we been involved in the project at the beginning, we would have took that $7,000 and put in, aero seal up the building, right?
Yeah.
Reduce the loads, reduce the thermal bridging by adding some exterior insulation in those areas that needed it, improve the windows. And all of a sudden that mechanical system is where it should be. And,
Hmm.
and the money has gone to where it needed to be rather than in the mechanical systems, which is, that's just barbaric. I mean, that's just old. That is so old school. And it's almost embarrassing to see it still happen today when we know not to do that kind of stuff.
Yeah, I think the takeaways as we sort of, summarize and reflect on our discussion is we've really hit on the things to pay attention to from a standpoint of selling hydronics. And obviously we can expand with individuals later, but if you get focused on comfort and if you get focused on the IEQ aspect of it, as a contractor or as an engineer, you're ticking boxes that are going to help that homeowner or that builder realize you're different. Because the other people coming in are only talking about their boiler or their water to water or whatever it is. And I know
Yeah.
for me, myself, I'm impressed with people's knowledge where they try to take that system and tie it to my environment and how I'm going to live. And I think the other thing that people need to take away from this, that, selling hydronics is also about putting together a package they can afford. And if you want to put together a package they can afford, as you've identified, right size it and design it, not in the mechanical room, right? Reach out to somebody who's a designer, whether it's our team or your team or somebody else's, and let's get a proper design that delivers the number one thing we're supposed to do, which is comfort. And then I wouldn't be driving to jobs.
Yeah, one of the things that we did towards the latter, say 25% practice, was to filter out, I don't want to say tire kickers, because everybody that came to the website was interested in what we were doing, but we really set up a filtering system. And what we said is that, if you looked at, and we classified it actually, class A, B, C, and D mechanical systems. And those systems were represented by a percentage of the capital cost for the building. So we would say, okay, well, a built to code system, if you said, 3 to 5% of construction cost was in the mechanical system, that would be a D grade system. That if you went to a C grade or a B grade, then you're going to spend considerably more money of that construction cost in the mechanical systems. And then when you got to like an A grade system, that was, that you needed to budget between 12 and 15% of construction costs. And that to you an indoor environmental quality, which was obviously not even in the same building, as a class D system. And it was going to be running at an efficiency level that the mechanical engineers designed into the heat pump or the boiler or the circuit or whatever it was. You're going to get that operation. And we would also then have a system, particularly if you're talking about decarbonization or electrification, that would have a really high exergy efficiency, looking at hydropower, wind power, photovoltaics, powering up a heat pump connected to large surface area heat exchangers like radiant floors. And you were getting incredibly high exergy efficiencies. You were conserving energy, and you were getting the energy efficiency out of the systems that you were designing. Well, you're not going to do that for 3 to 5% of construction costs.
Yeah.
You're going to get, a standard code built home, a furnace that will never run as it's supposed to run. You're not going to get the filtration that you should have in a space. You're not going to get the humidification or dehumidification in a space. Like, it's going to be a grade D home.
Yeah.
And when we had people come to our website, we would let them know that. We would say, like, here's your classifications, and there's going to be a fee for engineering these systems. And when we, at one time, like many, many decades ago, we did engineering as part of our packaged services. We didn't charge for the engineering. Well, there was a charge. It was actually parasitic on our profit. It was what it was, right?
Yeah.
When we stopped doing that and said, okay, listen, this is an engineering service. This is a design service. There is a cost associated with that. There has to be a profit expectation. And we would look at people ought to budget for engineering services. And so when we told them that there was going to be engineering fees, and they're going to be representative of a professional service, and that the classification of the systems that we were interested in doing, which is class A and class B systems, then we were a potential marriage between our client and ourselves. And then we would have that first conversation, which would be 2 to 3 hours, and they would pay for that. That wasn't free. We charged them. We got paid up front, right? And almost 90, I would say close to 95% of the projects that go, we got the engineering contracts, we got the, all of the stuff that was necessary to make that building perform, create the indoor environment, conserve the energy, make sure the systems were efficiency, and that we had exergy efficiency. That was a high, huge success rate for us. But it was because we filtered out everybody that came to our business first. We didn't have to deal with them anymore. In the past, we wasted so much time dealing with people who didn't want to spend the money or didn't want to learn, didn't want to become educated, right? That wasn't our client base. And so what we found as we implemented those procedures, that our clients, the intellectual capacity of our clients went way up. So I would say, again, and we've said this before, close to 90% of our clients were other engineers, because they get the science. And then the other 10% were made up either of medical professionals. So we had a lot of physicians, a lot of ophthalmologists, dentists, surgeons, right? And then I would say out of that 10%, 2% of those were just highly researched people, people that spent time understanding what it was that they were looking for. They weren't putting their faith in a builder. They weren't putting their faith in a contractor. They did their homework and they found us through their research work.
Well,
Right?
and so again, Robert, as we sort of pull the pieces together, again, if you're meeting with a builder and you focus on that comfort, that efficiency, that IEQ, and I love the list. We can do an A, B, C. D is here, but notice the line through it. We're not doing a D system, right? So if D is 3 to 5% and A is 10%, that gives them a
Or
point.
higher. Yeah.
One of the things I like to point out anytime we're doing discussions with contractors or engineers is there is this knee-jerk reaction. I have this reaction where it's like, okay, so I'm drinking matcha tea. That's why it's green, by the way. You know, somebody might go, well, that's a $3 tea. I can't afford a $3 tea. Well, Robert and I can afford a $3 tea. Don't assume we can't, right? And if you go to a customer and say, this is a $100,000 mechanical system, that's okay if there's a reason. Where it doesn't work and where it doesn't sell is when you walk in and do this. 100 grand, right? Like, I wouldn't even buy that.
Yeah, well, there, you know, if you think about the whole psychology of selling, and you know, we would shake our head at, particularly, you know, I mean, 40 some odd years, you get to work with some really good trades, and you also get to witness train wrecks. And you know, we would be involved in discussions with people about, you know, contractors in particular, and some vendors too, trying to save clients money. And I would just shake my head and I would say, when did you become the financial advisor to these wealthy people? Like, you know, it's like, if you don't get the money, right? Mercedes-Benz, Tesla, Ferrari, Porsche are going to get the money. The granite guys are going to get the money. You know, the vacation people are going to get the money, right? Grandma's going to get a new, you know, granny suite. Like, you know, you don't need to be their advisor. What you need to do is to understand what they're looking for.
Right. Well, it's the iPhone
Money,
mentality, right? I'm an Android user, and I make this joke with Mike Miller a lot, my dear friend. And you know, I would never line up when I have a perfectly good iPhone in my hand to go buy another $2,000 iPhone. But what I want is not what you want. I'm not the advisor on what Robert should use for a phone, right?
yeah.
And you're exactly right. When we talk about the selling systems, it's a fairly good argument. Go through that list we just listed and also include, would you like to go on holidays to be comfortable, or would you like to stay in your home and be comfortable? Because I know which one I would like.
Well, for sure. And, you know, and again, like, and we've talked about this before at different conferences. If you look at what people spend on pets, right? Vet bills, the pet vacations, the clothing for pets. I mean, I've had family members that, you know, that have spent more money on their pets than they do their indoor environments, right? When you look at people, not so much in the last couple of years, but prior to and after the pandemic, whenever that ends, you know, people will spend more money on moving
Yeah.
than they will on their indoor environment. People will spend more money on cosmetics. You know, I
Yeah.
used to joke about the poo and the goo machine, right? So poo is the pets and the goo is the makeup, right? We were competing against the poo and goo machines. I mean, the cosmetics that people spend, you know, thousands and thousands of dollars on creams and lotions and ointments and that kind of stuff, and that they won't spend it on upgrading their filter in their furnace. It's,
Yeah. And we're
you
literally
know,
talking hundreds of dollars to upgrade a filter versus thousands of dollars to
it's
do whatever.
insane, you know. And so if you think about moving, pets, cosmetics, outdoor furniture, you know, people will spend tens, 15, $20,000 on an outdoor, spend 5 grand on something to do with their indoor environment. You have to understand, people come to you with a checkbook, and that checkbook represents a certain amount of money that they're prepared to spend. And your job is to understand, well, what are your priorities here? And if this is a retirement home and this is the last home you're going to be in and you're going to die in this home, then let's start talking about air quality, because as you get older, your hygiene goes down, right? And you're not going to be able to change the filters and the bedding sheets and the towels and all those things that start to put off odor. So let's talk about ventilation systems. Let's talk about your inability, to program a thermostat because you've got cataracts. Let's talk about your inabilities to open a window to provide natural ventilation because you've got arthritis, right? Let's talk about your possibilities that you'll not be able to understand how to operate something because you've got onset Alzheimer's, right? But you still want to be at home. Like, let's just have some real conversations about real people in their houses toward the end of their life, right? And then start talking, well, are you going to spend the money on the cosmetics, or are you going to spend it on something else? Are you going to spend it on the outdoor kitchen, or are you going to spend it on something that's going to allow you to live in your home a little bit longer with a little bit more comfort and a little bit better indoor environmental quality, right? Those are real get that money from that client unless you have those discussions. They'll go spend it on that kitchen outside.
Well, and you make a great point, Robert. When you put it into that context, and that's a great context to have. I really like are you going to build an outdoor kitchen? So you're going to drop 25 grand on that. How about we put the 25 grand into your environmental quality so you're comfortable in the house? Like,
yeah, absolutely.
Where would you rather spend that money? And that's a way better conversation, again, than would you like a heat pump or an air to water? They don't know.
Yeah.
You have to decide that as the engineer or contractor.
Yeah, let me put, like, it's a good dialogue. We can spend a lot of time on this one alone, but just I'm going to give you one simple example, right, where people will buy, or they'll hire an architect, or they'll hire a builder, or even the mechanical contractors that are involved, both plumbing and heating and cooling, ventilation, the whole enchilada, right? And no one will ask the person when you're in the living room with guests and one of your guests gets up to go to the washroom and the washroom is adjacent to the living room and they go to flush the toilet, that people like to hear the sound of a flushing toilet. Everybody in the room, how many of you people have asked your clients that question? I ask it all the time. Nobody wants to hear it. So why do you put bathrooms next to living spaces where you do entertaining? And if you do, why are you not taking measures to reduce the sounds that bathrooms make and the people in those bathrooms? Those are real life questions that really happen, right? And people make a lot of assumptions or they don't address it, and then there's complaints.
Yeah. Well, and again, it comes back to that environment conversation, right? Focus on that and make sure people understand that we are trying to provide you with an indoor environment that you want to live in. And that's going to cost you money. And I definitely like the A, B, C, and the D, but again, with the line through the D of we're not doing minimum code.
Yeah, and people, going back to like the D grade house, like think about when you're in that marketplace and you're competing for the D grade business. So the D grade mentality is to lower the cost. Well, if the D grade is based on a 3 to 5% construction cost and you're trying to do it less than D grade because you want to be the provider of D grade systems, what kind of house are you going to get if you're going to spend D minus, right? And at some point you hit the F grade, right? Where the inspectors say you've dropped so low below the rating scale that we can't let you move into the house because it's a complete failure, right?
Yeah, I think when you put it into that perspective, it really, how does that not resonate with that builder or that end user, right? If you look at the average house price in Guelph, where I'm located and where the meeting's taking place, is in like the $700,000 range. So if you looked at putting $18,000, which is 3%, into your mechanical room, why are you putting more into furniture in your living room than you are into your indoor environmental quality? That's a fair question.
Yeah,
and
absolutely.
I think any husband and wife would look at that and go, why did we spend more on sofas than our environmental quality?
Yeah, absolutely. Yeah, and the same thing goes, when you start talking about kitchen ventilation systems. Again, like people, they read the magazines and they see all these, huge Wolf ranges, gas ranges, 6 burners and 150,000, 175,000 BTUs of gas, and you fired all 6 of them up at the same time, right? And conversations. Like, do you really need to do that? Because once you start to talk to them about their ranges and ventilation, the ventilation, the makeup air for these devices is bigger than the load in the home,
Yeah.
right? So you have to say, okay, all right, some people do a lot of entertaining and they actually, will use that device, but you have to say, listen, you can't just hoover up the inside of the house. Like, you got to address the exhaust leaving that home, and that means you're going to need to put in makeup air, and that makeup air is going to cost. There's a capital cost and there's an operating cost, and there's hazards associated with it. You take an attached garage, you put a house under negative pressure, whatever, minus 10 Pascal. Someone opens up the door with the car running, or they've got all kinds of whatever. I mean, everybody, think about what's in your garage. You got
Yeah.
paint, fuel, you got lawn chemicals, pesticides, herbicides, fungicides, right? All that crap puts off, toxins into the air. Well, you open up your garage door, you turn on your kitchen range, where the heck that air goes? People need to understand that, right? So do you need that great big range? If you do, well then fine. Some people do, but then you're going to have a proper exhaust and makeup air system. We were able to talk a lot of our clients out of these big, fancy brochure stuff. Well, what do you actually today? Like, go back and think about the last 30 years of your life. How many burners do you use at one time? 2.
Yeah.
Use 2 burners, right? So why do you need 6? Well, because we like it. Well, would you use it? Well, probably not. Well, use 2. Okay, well then you need a 4 burner device, right? So then we start talking to them about ventilation, exhaust systems, and properly designing a hood, and not buying the crappy Home Depot flat bottom, no sump, mounted like 6 inches from the ceiling. Like, that never works,
Yeah.
right? So you got to talk to them about hood design, which means they got to compromise on their kitchen cabinet design, which means the mechanical guys have to know about cabinet design, right?
Yeah. I mean, Robert, the more we talk, and I mean, we're big on doing training with our clients. So I think our clients are well positioned for this. I think that if you're going to sell systems, and forget if it's hydronic or not, the more you can know about that building envelope, the better equipped you are to handle that consumer, that builder, whatever the case may be. Take it off the equipment. Don't be focused on BTUs. They don't know what that means. Focus
No.
again on the comfort, the efficiency, the environmental quality, and upfront about costs. Give them,
Yeah.
here is option A. Like, which one do you want to be? Do you want to be the deluxe, or do you want to be the statistic? Do you want to see Mike, or do you not want to see Mike?
Yeah, absolutely right. And those headaches, when Mike shows up, that's just the beginning.
Yeah, I don't get
Right?
called to see good stuff. It's pretty rare people
That's
say, "Hey, Mike,
right.
drive 2 hours and check out this cool system." They just send me a picture, and I go,
Yeah,
"Sweet," and I put it on my LinkedIn or put it on social media. I share it with you and Siggy, and we love it.
yeah, absolutely. So part of what we would spend a lot of time going back to selling hydronics and integrated knowledge and all of that was teaching our clients to express expectations and knowing when to get involved and knowing when not to get involved. So when we were dealing with engineers, for example, they wanted to get involved, right? So so we taught them to express their expectations. So here's a typical thing that we would teach them. We would have them say to the builder and the architect and the mechanical contractors that we want to put in a 97% efficient boiler, and we want you to demonstrate that we're going to achieve that 97%. So that's our expectation. And here's our knowledge. To get that 97% efficient, we need water temperatures coming back at around 80 degrees Fahrenheit. How are you going to do it? That's my expectation. Now it's your job to fill it out, right? So we would teach them how to express expectations for lighting, sound, odors, vibration, thermal comfort, air quality, right? And then once they were able to express that expectation and then they handed it off to the design team, now the responsibility was in the design team and no longer in their hands. And if the sound sucked, if the air quality sucked, if there was vibrations, if there was an odor, whatever that came from, not my issue. I told you my expectations. You failed it. Now it's your problem, not mine. Fix it,
Yeah.
right?
Yeah.
If someone wanted to get into the nitty gritty, like they actually wanted to get into the specifics, well, then we would tell them as soon as you move from expressing expectations to now actually driving design, because you're an engineer or whatever, you have an interest in design, well, then expect to take responsibility, right?
Yeah, that's fair.
And if you want to take on that responsibility, great. Like we're doing a full renovation here in this farmhouse, and we have enough skills to take the building up to a certain place. Our ability is to do construction because of our experience in my history as a tradesperson, and then into construction engineering, mechanical. I can take it up to a certain level, right? But at some point, I have to hire somebody to take it up from my abilities up to the professional level. So in other words, we did 80% of the painting in this project, but we hired a professional to finish it off, right?
Mhm.
Well, it
Mhm.
just so happens on this particular project that we had some railings that were put in. Our expectations were that they were supposed to look like furniture. We wanted the staining to be professionally done. So we didn't do the staining because we're not professional stainers. We don't have the technique, we don't have the skills, we don't have the knowledge. So we hired somebody to do that. Well, they failed. Not my problem. We expressed our expectations and now the problem's in their hand. They have to fix it, right?
Yeah.
But if I told them what stain to use, what technique to use, all the strategy, well, now the problem's mine. Well, so don't take on responsibility, and this is our advice to our clients, don't take on responsibility for those things that you know nothing about, but you can.
Yeah. I'm never looking for a builder to tell me how to design a system, but there's a gray there because you want to have a collaborative discussion as you've just identified. There's nothing wrong with feedback. There's nothing wrong with discussions, but as I like to joke as we're talking with customers, I don't do my own surgery, right? So if my arm falls off, I'm not putting it back on. So I would also question, why is the dentist, doctor, postman, factory worker telling me how to do my job, right? You're not qualified, or you would be doing my job. And
Yeah,
I think outlining expectations both ways is a great way to build trust with that builder and with that end user.
yeah, for sure.
So. Well, awesome, Robert. I certainly appreciate all your time on this. I think we got to wrap up. Obviously, we'll do this again soon.
Yeah, I mean, these are big discussions, and as you know, we could spend hours and talking about that, but it's not difficult to sell hydronic systems. You just have to stop thinking that is the icing that they're looking for. They're not. They're looking for good indoor environmental quality. They want systems that are efficient. They want to conserve energy, and hydronics is an enabler. That's the best way to look at hydronics. It's an enabler to deliver the environment that people are looking for, and with a value proposition in terms of energy that's hard to beat.
Yeah.
So you just have to look at it that way. And as soon as you do that, and as soon as you start understanding integrated design, your success ratios go way up.
Yeah. And I think you hit the key word there, Robert. It's discussion, it's collaboration, and it's design.
Yeah.
It's my family's been in the HVAC business for multiple generations, and I always like to tease my father, who is a client of Eden Energy, that, Dad, I know you don't like how we do things now, but again, things change. There's smarter, easier, faster ways of doing things, and we have to adopt. And this idea that hydronics has to be more expensive or less comfortable, that to me just speaks to inexperience. If you're an experienced installer, an experienced engineer, we can tick a lot of boxes very easily doing a hydronic system.
Yeah, for sure. Awesome. Well, listen, Mike, and everybody else that's there, congratulations again on your 40th plus one anniversary. And wish I could be there, but I'll send in best regards from the mountains because we're leaving tomorrow morning first thing, and it's a 5-day trip. Rockwall. Anybody's ever heard of it? It's a great hike, and we're gonna have a lot of fun on it. So.
Well, as always, my friend, I appreciate your mentorship, your friendship, and I look forward to many more years working with you, even though you're pretending you're retired.
Likewise. Cheers.
Thanks, buddy.